Yellowstone Caldera is a weekly column written by scientists and collaborators of the Yellowstone Volcano Observatory. This week's contribution is from Michael Poland, geophysicist with the U.S. Geological Survey, and scientist in charge of the Yellowstone Volcano Observatory. Yellowstone is a very active place in terms of seismicity. Typically, the University of Utah Seismograph stations, which is responsible for the operation of the Yellowstone Seismic Network and analysis of seismic data, locates 1,500 to 2,500 earthquakes every year in the region. The past 3 years have seen earthquake activity on the lower end of that spectrum, with fewer than about 2,000 located earthquakes in 2018, 2019, and 2020. In 2019, there were only about 1,200 located seismic events. In 2021, Yellowstone saw a return to the higher end of that average, with 2,773 located earthquakes. The largest event of the year was an M3.6 earthquake that occurred beneath Yellowstone Lake on July 16. That event was part of an earthquake swarm beneath Yellowstone Lake that included 825 located quakes. A swarm is a sequence of earthquakes that occur in roughly the same place in rapid succession, and on average about 50% of all earthquakes in Yellowstone occur as part of swarms. In 2021, there were a total of 27 earthquake swarms, and these accounted for about 65% of located earthquakes during the year. The vast majority of Yellowstone earthquakes are very small, over 90% are in the range of M02. In 2021, there were 10 M3 events located in the Yellowstone region, and over 150 M2 events. These numbers are pretty typical for Yellowstone in a given year. The abundant seismicity is caused in large part by groundwater interacting with existing faults, two things that the Yellowstone region has in abundance. GPS data did not detect any significant changes in surface deformation over the course of the year. Data from the caldera showed that the region continues to subside, as it has since 2015. Each summer, that subsidence pauses and may even turn to a slight amount of uplift as runoff from spring snowmelt percolates into the ground, which soaks up the water like a sponge.